Hello everyone and welcome in this channel. So today we're gonna talk about buffer overflow attack. I will share with you a summary of what I have understand, meaning my experience after doing some CTFs and following online courses. And by the way, this attack is included in the program of OSCP and PNP2 certificate, which are known certificates. So OSCP stands for Offensive Security Certified Professional, and PNPT stands for Practical Network Penetration Tester. So without wasting time, let's get started. So buffer overflow is an attack that happens in the memory. There are two types of this attack: stack-based buffer overflow and heap-based buffer overflow. Well, in this tutorial we're gonna focus on stack-based buffer overflow attacks because they are more common. So stack is a section of a memory that stores temporary data that are executed when a function is called. So suppose that we have a C program here. Here we have a main function that will call a function called function1. Then it will assign 2 to the C variable. So in the memory we have a section allocated for this main function, and when we call function1 there is a stack space that will be allocated for this function1, and this space it's include the ESP register, the EEP and the EBP. So ESP is used as a stack pointer to keep track of the top of the stack. It changes as the stack grows. The EBP CPU register, it's commonly used to store data used in calculation. And finally, EIP contains the return address. It points to the next instruction to be executed. So in our case, suppose that this function1 will create a buffer, a string here of 100 length, right? And so when we arrive to this instruction, the EIP must save the address of this instruction so that when it finishes the execution of this block of code here, it will come back to this instruction. So here we will save the instruction of the address of the next instruction, address of C equal to 2, right? Then when we start the execution of this function, a space will be allocated to this buffer to contain this buffer, right? After that, when we finish execution of this instruction, the program will come back to this address and will execute this instruction C equal to 2, right? But in a buffer overflow attack, our goal is to arrive to this register, CPU register right here. So suppose that we are here. We need to overflow all this space with letters like A or another letter. So we try to overflow all this space to arrive to the EIP, when we arrive to the EIP, we will put an address of ESP to jump to ESP. Then we will execute our payload that will give us a reverse shell, right? So the goal here is to overflow this space and arrive to EIP. And by the way, the address that will the instruction that will allow us to jump to ESP is jump ESP. So we will search for the address of this instruction. We will put it here. That will jump to ESP and execute our payload, right? So it can be a little bit complicated. It may seem a little bit complicated now, but I will go a little bit in depth and explain all the steps one by one to make it a little bit clear, right? Okay, so now we will talk about the steps of buffer overflow attack. There is 8 different steps. The first one is spiking, and in this step we will identify which command of program is vulnerable. So if I take example of VLAN server, which is a vulnerable server used generally to learn this type of attack, I will try to connect to this server. It's in port 999. I will launch it from the other machine. And here he asked me to type help to get the menu. Right. And here I show I see a lot of commands: stat, airtime, ltime, and so on. So in the spiking phase, we will try to perform overflow attack on all these commands to check whether these commands are vulnerable or not. And to do that, we will use a program called generic send TCP. So this program will take the host, the IP address, the port, in our case is 9999, then the script, and this script will set a value to a command, for example here 0, and these 2 values we will keep them for the moment. We will set them to 0. So the generic send TCP will try to send a lot of command, a lot of letters, many times, in order to check whether the command is vulnerable or not. So once we identify the command that is vulnerable to buffer overflow attack, we will jump to the next phase, which is fuzzing phase. So the next phase is the fuzzing phase, and in this phase we will try to write in the buffer space the letter A. For example, here we will write A 8 times in each iteration, and we will increase this number in each iteration, and also we will print the number of bytes in each iteration. And at the same times we will launch immunity debugger that will simulate the program, that will try to that will show us what's happening when the vulnerable program is running. So in immunity debugger we will see the contents of memory, the contents of register keys, and so on, and we can also run softwares like Muna, which will help us a lot in the buffer overflow attack. And the most important part here is the program is to check whether the program crashed or not. So when we launch the Python code from our Kali Linux machine, we try to see when the program will crash. And when it's crashed, we will press the Ctrl+C here to check the number of bytes that crashed the program. So to resume, the goal of this phase is to get the number of bytes that will crash the program. Once we get this number, we move to the next phase, finding the offsets. So the goal of this phase is to find the number of bytes just before the EIP register, and that's what offsets mean. So we will use a program, pattern create .arb, that will generate a pattern for us, a string for us that has the same length of the letter that have crashed the program in the previous step. Then we will add the generated pattern in our Python code here. So we will replace this letter with the pattern. We will send it, and we will see from Immunity debugger that it will crash the program. But in this step, we will be interested to the offsets. So we will run a Muna program that will tell us the offset, that will give us the offset. For example, here, I will make full screen. The offset is 1978. So EIP contains normal pattern, and the offset is 1978. So now we get the offset, we move to the next phase. So in the next phase, we will overwrite the EIP, and the goal here is to confirm that we get the right location of the EIP. So we will write A at the number of offsets, so 8 times offset, plus B times 4, since the EIP is 4 bytes, has a 4 bytes. And as I have just said, our goal is to confirm that we get the right place of EIP. So when we generate this, we will add it to our Python code. So we will replace the A with this new string here. The A that are here, we will replace them with this string. And from Immunity debugger, we check that the value of EIP is 42, 42, 42, which corresponds to the B letter. Now we have confirmed the location of EIP. Next, we will find the bad characters. And bad characters are a kind of characters that can break our payload, and in this case, it will fail to overflow the buffer. So if I take the example of hex of 00, which represents the null byte, which is used to terminate string. Another example is hex of 0D, which is used for carriage return. So when these bytes are sent to the memory, they might be interpreted in a different way, and our payload won't work as expected. That's why we need to find them and remove them from our future payload to avoid this kind of problem. So in order to do that, we will generate a list of potential bad characters. We will add them in our Python code and send them to the vulnerable program, and then we will use a Muna tool to make a comparison between the original list and the content of memory. after interpreting this letter. Then Muna will tell us the list of bad characters. And once you identify the list of bad characters, you need to remove them from the payload and send it again, and repeat this iteration again until you get unmodified here, an empty list here and unmodified. And this may make you a little bit nervous because it take a lot of time, right? Next, we need to find a jump command, because as I have said at the beginning, we need to put here the address of jump to ESP to jump to the ESP which will run our payload. Same thing, in order to find a jump command, jump ESP instruction in the vulnerable program, we will use Muna tool. Again, it may seem a little bit complicated, but it will be clear when we will make all this in practice. Next, we will generate our payload, and we prepend nopes. So in order to generate a payload, we will use MSF Venom. We will give it our local address and the ports to listen to. By default is 444, and between our payload and address of jump, we will put nopes in order to avoid having something that can interfere and break our code. So nopes, it corresponds to hex of 19. So to resume, we will make a letter A times offsets, which is the number of bytes just before the EIP. Then in EIP we will put the address of jump ESP command to jump to the ESP. We will put nopes to avoid problems, and finally we will put the payload that will give us a reverse shell, and that we have generated with MSF Venom command. Finally, we launch our code, and we get a reverse shell. So we need to launch a listener here using a netcat command, and we get a reverse shell to the vulnerable machine. So to resume, there is 8 steps. The spiking step, which consists of checking whether a command is vulnerable to a buffer overflow attack or not. In the fuzzing phase, we will determine the number of bytes at which the program will crash, finding the offset, which is the number of bytes just before the EIP, overwriting the EIP, and here the goal is to confirm that we get the right value, and we should find in the content of EIP register, we find the value of letter that we have sent. In our case, we have tried to send the letter B, so we should find 42, 42, 42. Next, we find the bad characters that are characters that may be interpreted on another way, and that may break our program. Then we find the jump command in order to jump to ESP and put this address in EIP register. When we jump to ESP, we will run our payload, and of course we put nopes in order to avoid problem. Finally, we run the exploit and get a reverse shell. So that's all for this video. I hope that is clear for you, and I hope that you have understand how buffer overflow attack work. If you have any question, please leave your question in the comments. Thank you.